So here is a question on the geometrical interpretation of scalar triple product, which is the volume of the parallelepiped. So it is given to find the volume of the parallelepiped with its coterminous edges given by the vectors A vector 6i cap, B vector 2j cap and C vector 5k cap. So we know that the volume of parallelepiped, which is represented in terms of its three coterminous edges A vector, B vector and C vector, that is given as the scalar triple product of the three vectors, which is A vector dot B vector cross C vector or A vector cross B vector dot C vector. Whichever way you go, you will get the same result. Okay, so here A vector is 6i cap, so it will be 6i cap dot B vector cross C vector, that is 2j cap cross 5k cap. So this becomes 6i cap dot j vector cross k vector is I cap. That is the rule of cross product or vector product, which we have already discussed, and we have solved a lot of problems related to that. You can watch those videos. So this becomes 10, 2 into 5, that is 10, and j vector cross k vector, that is equal to I cap. So this becomes 60 I cap dot I cap, which is equal to 1. So this becomes 60 cubic units. Okay, this is through this A vector dot B vector cross C vector. So if we go by this method also, we'll get the same result, that is 6 I cap cross 2 j cap dot 5 k cap. So this becomes I vector I cap cross j cap, that gives us k cap. Again, rule of cross products, this becomes 12 k cap dot 5 k cap. So this becomes 60 k cap dot k cap. Again, unit vectors dot product, that is equal to 1. This becomes again 60 cubic units. So both ways you will get the same result. So this is the volume of the parallelepiped, which is given in terms of its three edges, represented by the vectors A vector, B vector and C vector. So here is another question on volume of parallelepiped with its coterminous edges, which are represented by vectors. Here A vector is 2i cap minus 3j cap plus k cap, B vector is I cap minus j cap plus 2k cap, and C vector is 2i cap plus j cap minus k cap. So again, the volume of the parallelepiped that is equal to the scalar triple product of the three coterminous vectors, okay, which are the edges. So in determinant form, we'll represent it 2 minus 3 and 1, the x, y and z components of A vector, then 1 minus 1 and 2, and here it is 2, 1 minus 1. Okay, so here we can do some manipulation in rows to simplify it. So we can do R1 is equal to R1 minus 2R2 and R3 is R3 minus 2R2. Okay, so it will become R1 minus 2R2. So 2 minus 2, it becomes 0. Then minus 3 minus minus 2, so that becomes minus 3 plus 2, that is minus 1. Then 1 minus 2 into 2, 1 minus 4, that becomes minus 3. Okay, row 2 remains as it is, no change. 1 minus 1, 2, and then R3 minus 2R2. So 2 minus 2, again it becomes 0. Then it becomes 1 minus 2 into minus 1, so it becomes 1 plus 2, so this becomes 3, and minus 1 minus 2 into 2, so minus 1 minus 4, that becomes minus 5. Okay. So our objective was to bring it in this form 0 1 0. If we go by this first column, it will be 0, so it will be anything multiplied with what? It will become 0. Then it will be minus 1 into minus 1 into minus 5, then minus, then it will be minus 3 into minus 3, then again plus 0 into whatever it is, it doesn't matter, it will become 0. So this becomes minus 1 into 5 minus 9. So this becomes 5 plus 9, which is equal to minus 14, as volume cannot be negative, so it is the modulus of that, so this becomes 14 cubic units. Okay, only the magnitude is taken into consideration. Okay, that is the volume of this parallelepiped with its coterminous edges represented by these three vectors. Okay, so if you don't do this row manipulations directly, if you also calculate, you will get the same result. So if you want to go by this, manipulate the rows to bring it into a simpler form so that you can do it only in one calculation, you can do that. Otherwise, directly also, without any row manipulations, directly you can also calculate, you will get the same result. Okay, so let us do that also to show that it will give us the same result. So 2 minus 3 1, you can go by that, so it will become 2 into, that will become minus 1 into minus 1 minus 1 into 2, then minus of minus 3 into 1 into minus 1 minus 2 into 2, then plus 1 into 1 minus 1 into 2. So this becomes 2 into 1 minus how much? 2. 1 minus 2, then plus 3 into minus 1 minus 4. Okay, then plus 1 into 1 minus 2, so 1 plus 2. So this becomes 2 into minus 1 plus 3 into minus 5 plus 1 into 3. So that is equal to minus 2 minus 15 plus 3. This becomes minus 17 plus 3, which is equal to minus 14. Modulus of that, because volume cannot be negative, so it becomes 14 cubic units. Okay, same result you will get. Okay, so either you do the manipulations or not, but this will become a bit lengthy, so we can go by this. Okay.